Abe, you can get started.
Am I on?
Yes.
Okay, perfect. Let me just make sure I share my screen. Hi, so just want to make sure everyone can hear me. Perfect. So today I'm going to talk a little bit about Granite Guardian. As part of the overview, I'll walk through the ecosystems of models, share a little bit about what they do and how you can use them, and then kind of talk a little bit about some of the partners that we work with in order to drive adoption. So our Granite family of models, enterprise models, kind of covers across three different scopes. So we have our Granite language models, and these are really our performant models. These are our cornerstone, where they're going to be typically used for most use cases. So as part of our 3.1 release, we've actually built on top of our 3.0, and now we can support 128K context length. So these focus on, this language model, we focus on, our dense models and our MOE models. As I had mentioned, kind of the driving force is our 8B, which is, our most performant model. But in order to support some of those edge cases or compute low environments, we've also developed our MOE capabilities across a 3B model and a 1B model. And what's really great here is that in terms of actual inference costs at time, or compute costs in type of inference, you're really looking at...
Hey, Abe, your screen share isn't working. You need to reshare. I'm sorry to interrupt you.
No worries. Can anyone see now? Can no one see still?
It's getting better. I can see something. Can you...
I'll stop sharing and then reshare.
Yeah.
Share screen, entire screen. Is that better?
Yes, much better.
Sorry. Awesome. No problem. So should I just start from the beginning?
Yes.
Okay, great. So again, as I mentioned today, we're going to talk a little bit about Granite, more specifically Granite 3.1. Talk a little bit about what models actually are included in the Granite ecosystem, some of the ways we can use them, and then some of the partners that we're working with. So as I mentioned earlier, so the Granite models, our Granite language models, we've led with our Granite 3, which just released this past December. And one of the key features that was released as part of our December launch was our 128K context length. So as part of our Granite language models, we've got our dense models as well as our MOE architectures. And really the focus across those two is, our dense models are really our most performant models, more specifically our 8B, where these are going to be used again for our the majority of use cases. But for those compute restraint environments, or if you want to run on your laptop or on the edge, we've also released our MOE models in 3B and 1B. And the big key here is that, from an inferencing cost perspective, you're really only getting 800 parameters of an expense at the time of prompting. Along our Granite language models, we also have our Granite Guardian models across 8B and 2B, and I'll talk a little bit about those in a bit. And then lastly, we actually open sourced our Granite embedding models across 4 different weight classes, supporting both English and multilingual. And again, we'll talk a little bit about that. And all of these right now are available on Hugging Face, as they are available to be pulled down. Weights are all accessible, all under Apache 2 licensing as well. So again, this is just a further commitment to IBM's open source initiative. So talking a little bit about our Granite 3.1 models. So we've trained on 12 trillion tokens. So just to kind of give you context, our first model that we launched was actually trained on 1.25 trillion tokens. So just, a clear indication of the sheer size of not only our training corpus, but how far we're coming in terms of being able to annotate, filter, and engineer high quality curated data for end users. As I had mentioned, all of our models are right now fully open sourced on Hugging Face, as well as available on some of our partner platforms. We designed these models to support a number of different enterprise tasks. So for 3.1, we've tried to, bake in a lot of capabilities into our single model. Our original, so like if we look about what the roadmap has looked like for Granite, so 3.0, our initial kind of entry into the LLM space really supported only a standalone language model. And then we also had a standalone multilingual model. And as we move to continue to drive performance, our 3.1 Granite entry into the market, we again supported language, supported multilingual, and we added a code capability as well. Now, all these kind of stood on their own as individual models. So what we're really proud of as Granite 3.1 is we've now started to consolidate capabilities within the model. So our 3.1 supports language, multilingual, strong code performance, but we've also included agent and tool use, and I'll talk a little bit about what that looks like. And then again, with the 3.1, where we went from 4K previously, now we've been able to extend our model context length to 128K to support some of those, multi-document ingestions, some of those use cases that, are required for RAG type or RAG agentic use cases. So again, and we're going to continue to drive this and of course, improve performance across English and multilingual and kind of doubling down on that. So what we can see is for our particular Granite 3.1 8B model instruct version, we're really competing with state-of-the-art models within our weight class. So what you see in front of you is the Open LLM V2 leaderboard for the Granite 8B model, which basically benchmarks our model across different tasks from instruction following to math and science, multi-turn conversations. And what you can see here is when we stack up against, Llama 3.1 8B instruct or Ministra 8B instruct, or some of the bigger models like Gemma 9B, IBM is right there neck and neck in terms of performance, which allows us to not only compete in the market, but as you can see as part of our average, although we do kind of balance out in terms of some of the individual benchmarks, on an average, we do outperform our competitors. So not just to focus on benchmarks, we also take a lot of pride in the safety behind our Granite models. And one of the ways that we've done this is to be able to curate IBM data hyper-specific on bias, harm, PII, violate. So this was actually curated by a dedicated team here at IBM. And the attack data set kind of identifies certain areas where our models are, we want to see robustness in our models when it comes to being able to manage any sort of attacks. So you can see here, the bigger the square, the bigger the actual area, the better. And again, we're comparing across similar models for same weight class. And again, average score of the attack dimensions demonstrate the safety of our models. And we've only continued to drive, red teaming, working with external partners, as well as continuing to build out our internal data sets. Now, kind of coming back to the focus of IBM's models where, enterprise is at the center of what we try to do. Kind of talked a little bit about the function calling tool support earlier. So key feature is the ability to work with tools. So models can call external tools in response to user prompts. We can also work with integration of tool responses into answers in a streamlined and efficient way. So this is all done through an updated chat template. So we tested the chat template to be able to provide a clear framework for developers. And the template defines available tools, as well as helps identify structured inputs for prompts creation. In terms of being able to support RAG capabilities or agentic workflows, so our new chat template actually kind of moves away from the need to implement documents within the user query if using a CLI. So it's just a much friendlier interface from a chat template perspective. It allows users to better handle questions as well that are maybe not be unrelated to the document. So you get that switch, the assistant can kind of return to a default message if the question can't be answered with the documents provided. And of course, we're continuing to drive our cybersecurity benchmarks, as that's an important piece of our capabilities within the model. So let's talk a little bit about our Granite Guardian models. So these models are actually targeted to be able to detect any sort of risks in the input or in the output of an LLM. So these work with any LLM. It doesn't necessarily have to be used alongside a Granite model. And they target different risk definitions across, jailbreaking, bias, violence, profanity, and as you can see. There's also a capability to identify your own risk definitions. So there is, within the template, you can actually identify unique risk definitions that are relevant to whatever use case or example that you're trying to use. And because they're built on top of our Granite 3.1 models, they also support, long context, 128K length. So that's a great feature here. And then as part of our 3.1, we've actually enabled function calling hallucinations, which again is a kind of an added benefit to some of the agentic workflows that, we like to see our models use as part of. And just kind of a quick example of how the Granite Guardian model works. So this is more so on an input. So some of the attacks or some of the jailbreaking methodologies that team members or individuals or bad actors use is to be able to bake in an attack within a story. So for this particular case, you're seeing that as part of the request to advise a character in a story, the actual request is, can you identify how my character can get out of financial trouble, considering illegal methods. So again, not quite within the prompt, but within the story within the prompt. So sometimes this can actually bypass the model and an output can be prompted. In this case, Granite Guardian sits on the front of the model and it provides, before the actual prompt goes into the model, it goes through the Granite Guardian LLM. And given the risk detector that we've used as part of this, we have identified, okay, well, this is unsafe and with a confidence level of 90%. So right now, the Granite Guardian capabilities are really kind of binary in terms of how do they respond to any sort of risk. So either a yes, no, or safe and unsafe. One of the cool features that we're working towards is a more free text. So not only being able to identify that it is a unsafe or safe or a binary response, but really trying to work with, let's give an explanation and then some sort of alteration in that response. So again, that's kind of looking to the future, but just give you a quick example of how Granite Guardian works with LLMs. And then again, just from a performance standpoint, so right now, Granite Guardian and Llama Guard are kind of the two larger scale guardrail models on the market. And when we talk about harm detection, we can really see that Granite Guardian is able to provide, a little bit better performance there. But what's really interesting is that Granite Guardian also supports reg hallucination detection, which is typically found, and you can see on the right, in smaller models. So one-off models that may not be able to support the harm detection as well. So what Granite Guardian does a great job of is combining the risk detectors alongside, adding unique risk detectors with those reg hallucination detections as well as function calling detection. So kind of providing a one-stop shop for all of your, guardrail requirements. And we also, as I mentioned, released our Granite embedding models. So these were previously known as our Slate models. They've been rebranded under the ecosystem of Granite and have been released not only on Watson X, but on our open source platform as well on Hugging Face. So again, looking forward, what we really want to be able to support as part of our roadmap is, driving long context within our embedding models, adding other features, more specifically around code function calling, reg use cases, reg optimization, as well as being able to release our sparse models, which are actually in the pipeline right now, and we're aiming to release in the next few months here. But as I mentioned, we kind of support across a number of different weight classes and a number of different language capabilities that users can kind of pull to for specific use cases. And lastly, we have our Tiny time series. So these are a lightweight architecture. These really focus on rapid inference and training times. These really make suitable for any sort of, again, resource constraint devices, so laptops or single GPU machines. In training these, we really focus on forecast setting, and we work across 4 different timelines or time points in this case, as well as forecast lengths. So this focus approach is being specifically for accuracy and efficiency. And in terms of, supporting exogenous variables. So the model comment exogenous and control variables. So, and how we do that is the Tiny Time series R1 was pre-trained on approximately 250 public training samples, while R2 was trained on roughly 700 million training samples. So again, all of these are available under our Hugging Face collection under Tiny Time series. Some of the practical applications we see our users are, energy demand forecasting. So we've actually demonstrated this as part of our Granite workshop. So predicting future consumption trends based on historical data. Another use case that we've seen is air quality prediction. So, air quality indices using historical pollution data and any sort of like meteorological data that you may have on hand. So as part of our 3.0 release, we have released a technical paper. It can be found on our GitHub as well as on our Hugging Face page. And as part of that, we identify, the full scope of training. So, how we actually went through the engineering process, our model architecture. We outline the data that we use. We also speak a little bit about some of the techniques we use for evaluation. So, if you have a moment, I implore you to go out and read it. And our 3.1 technical report is in draft right now, so we're hoping to release that soon, and that'll talk a little bit about some of the enhancements that we've done to a 3.1 model. And of course, a lot of this couldn't have been, successful without some of the partners that we worked with. So, these are some of the key partners that IBM has worked with in order to drive developer adoption. One of the key partners is on the call here, Eli with Docker. So why don't I pass it over to him to talk to you a little bit about what Docker's doing.
All right. Thank you, Abraham. Hello, everyone. I'm Eli. I'm with Docker. And I wanted to take a slightly different approach to what Abraham was just talking about and talk less about the models themselves, but how to enable developer productivity when using those models. Briefly about myself, I'm head of technical alliances over here at Docker. Previously was with various technical companies, including Pivotal Software, VMware, Microsoft, and was actually one of the early engineers on AWS. So when we think about the AI experiences and when we think about, what their user experience is this easy box on the left, which is a simple user interface and just a box that they can interact with. But what's behind the scene is oftentimes quite complex. What you're seeing on the right over here is a reference architecture blueprint for a rack flow, which actually has a number of boxes and it's a number of components in it. And it's actually not that easy to put together. We're still in the early ages, but what we're clearly seeing already is that those experiences that when looked from the outside look magical and contain a model inside of them are actually composed of a lot of complexity, right? When we think about developer productivity and we think about how do we make developers more productive, there was a study that came out a few years ago about what does actually make developers more productive. And there are three main components of making developers more productive. One, reducing cognitive load, reducing the number of things that developers need to think about when they're building and when they're debugging their application. Two, while reducing the cognitive load, also shortening the feedback loops, right? Enabling developers to be able to get feedback on what they're building as quickly as they possibly can. And through that, enabling them to stay in the flow state for longer. Flow state is a state in which developers are actually producing and making things happen. So when you combine those three things, this is when developer productivity increases. And for us at Docker, we take this to heart and we think about how do we help developers to reduce cognitive load, enable them to get much faster feedback loops, and increase the amount of time they spend in this state of flow. The other thing that we're starting to observe over here is, especially over the last couple of years, is we're starting to see two worlds morphing together. Right? We're starting to see a world of traditional AI developers. Those are people who are building models. Those are people who are Python native, who view the model is as the artifact, the thing that makes that they are working on. And the world of application developers, those are the traditional application developers who have been building applications in Java, Golang, .NET, and others. Uh, and for them, the LLM is just one component of the experience that they need to build. And what we're seeing is we're seeing those two worlds morph together. And what we're also seeing is that oftentimes the language, the two speak to each other, AI developers and application developers, that language becomes containers, right? This is a primitive that application developers have used for many, many years. This is a primitive that is used for application deployment and application development for many years. And this is also the primitive that is becoming the primitive that the AI developers ship and interact with application developers through. Through that lens, what we're also seeing is we're seeing the rise of smaller LLM models, right? When AI in popular culture kind of came out to the scene, everyone was talking about cutting edge models and ChatGPT and Anthropic and so on and so forth. But what we're actually seeing is in a lot of enterprise use cases and a lot of use cases all around us, is that the smaller LLM models are actually starting to become a lot more popular. And they're being used for a variety of use cases, right? They're being used for post processing, for example, when one targets a larger model. We're seeing them being fine tuned and trained for specific tasks. We're seeing them being used for testing outputs for hallucinations and other things. Through that lens, what we're seeing is we're seeing kind of two types of applications. We're seeing applications that leverage cutting edge models that are hosted places. But even for those, we're seeing people who are leveraging smaller models in conjunction and people who are using smaller models on their own. And when we peel back the onion and when we start looking at how do people actually ship such experiences, right? For when we look at this, we see, hey, the model itself becomes data. And the way people try to expose those models is through a pattern that we're seeing over and over again, right? The pattern is they're trying to create a container with an API server on top of it so they can talk to it, an inference engine, and there are multiple that exists, and the model file itself. And this becomes a component in their architecture. When we look at it through the lens of infrastructure, what you're seeing on the right is we're seeing how this looks like in Docker Desktop. In Docker Desktop, this becomes you have a container which is your application, you have a container which is your data store or multiple data stores, and you have a container which is this container for the model, API engine, inference engine, and so on and so forth. And that becomes just one part of the building blocks. And what that enables developers to do is to leverage those models and to be able to version those models and to be able to build with those models as if though they were part of any other part of their normal architecture. It allows them to use tools for development such as Docker Compose or test containers to be able to iterate on those experiences as quickly as possible and to be able to stand up local experiences, and then also to be able to leverage tools such as the tools that they're already familiar in CI/CD or Kubernetes solutions when they're deploying this up to the cloud. Right? And this is why I'm particularly excited to talk about some of the work we've done together with IBM to go and expose IBM Granite models through containers which are available on Docker Hub today. Right? And that is also exposed through Docker Gen AI catalog that we've launched in November, which has everything one needs in order to go and start building applications with containers using Docker. And things that are included in our Gen AI catalog are models, the IBM Granite models, frameworks, MCP servers, which is an interesting addition that has happened over the last little while, application end-to-end platforms, vector databases, and many other components one needs in order to go and build applications with Docker containers in AI. And we're very excited to have had IBM as launch partner of the Gen AI catalog and a key member of that experience. So with that, I just wanted to close really quickly with this idea that AI developers and application developers, those worlds are morphing. AI and LLMs are here to stay, and developers are looking for ways to consume those applications. We need to allow developers to reduce cognitive load, allow for shorter feedback cycle, and maintain a state of flow for longer. And I'm very excited about the partnership between us and IBM, which is helping developers to go and achieve those. Thank you. Brad?
Thank you, Ellie. Let me go ahead and share my screen. Hopefully everyone can see my screen. Oh, that's a good sign. Okay, so I'm going to finish up this wonderful presentation with talking about how you can get started with Granite. And getting started with Granite is easy. You can use your favorite tools and services. We've got a lot of what we call 5 minutes to fun activities with Granite recipes. As Abe mentioned, there's lots of versions of Granite, and we have some that will run on your laptop. And you can do some fancy stuff as well. And then we built some sort of end-to-end applications for inspiration. So we'll go through all of this. The nice thing to know about Granite is it works with your favorite tools and services. So, on the services sides, maybe use Ollama, maybe use Replicate, maybe use LM Studio or NVIDIA. All of those, we have Granite working. And then, of course, what's getting very popular for agentic workflows are these LM workflows. So whether it be LangChain or Crew AI, we've got Granite working with those. And obviously, if you want to pull in documents, Dockling has been very popular. So a lot of great tools that we've already got Granite integrated with. We have lots of what we call 5 minutes to fun Granite recipes. So recipes for key tasks, whether it be summarization or entity extraction or doing RAG or multi-document querying. All of those are supported, and we have recipes for them with Granite. Granite's also really good at code generation. Again, you can really trust it because it's, as Abe mentioned, we've put a lot of work into making sure it was curated. You can trust what it's giving you. Another nice, unique feature that we have with Granite is time series forecasting. People really do like the time series support. And of course, as I mentioned, the Guardian models. So lots of Granite recipes, and there's links here that you can go kick the tires on those. A lot of them are in easy to run Python notebooks. So that makes life pretty easy, very easy to set up, run end to end. We also have cloud hosted options. So you can run your notebooks in Colab and take advantage of free cloud GPUs. So look for that option as well. The Granite models are lightweight enough to run on your laptop, and we've actually, on the Ollama Discord server, we've gotten some really nice feedback, and so folks are using it and saying, "Hey, this is fast and giving good results." So it's nice to hear some nice comments from other folks in the community. And I've said it's light enough to run on your laptop. So why don't I show you a demo of me doing that right now? So I'm going to go pull up the environment that I have here is I have the Granite 3.1 dense model. So I've got a pretty decent model running on my M3. I'm using anything LLM as my front end, and on the laptop, the provider I'm using is Ollama. So I've got, it's very easy to set these things up and get Ollama running with anything LLM and pulling down a Granite model. It's very straightforward. And so, what I can do is I can ask a simple question. I'm going to create a workspace first. And I'll ask something easy. What is a recipe for ravioli? So the Granite model's running, and through anything LM, I'm getting a nice little recipe for ravioli. So that's kind of cool. But let me create a new workspace. And what can happen is maybe I'll ask something that the Granite model doesn't know. What was the discretionary presidential budget in 2024? Okay, so this Granite model doesn't know about that presidential discretionary budget in 2024. But again, Granite, there's ways that you can fine tune and add information to your models. So I'm going to set up a new workspace. So we're going to add budget 2. And I'm going to upload a document. And so this is going to allow me to demonstrate through anything LLM, just a pretty basic RAG approach. I'm going to pull in a PDF. I'm going to click on that PDF, and I'm going to do move to workspace, and then I'm going to do save and embed. This will just take a few seconds, not too long. Again, this is leveraging Granite, leveraging these open source tools that are all running on my laptop, and we're doing a very nice version of RAG to pull it in. Okay, so that's successful. So that's good. So now if I ask that same question, here, it actually now knows the answer. So why does it now know the answer? Because we've got the Granite model plugged in, and we use the RAG technique to pull in new content through a PDF. It came in as a PDF, but it goes into a vector database. And you can even see, you can click on it if you want to see how it broke it up into chunks. I don't know if you're familiar with the RAG technique, but you break things into chunks, and then it'll pick the chunks that seem like the best match. And behind the scenes, what was happening is it was getting passed into the context. And so the question has the context passed into the Granite LLM. And now with all that wonderful magic, the model has been, essentially the model is now able to answer questions it couldn't answer before. So again, the RAG technique is wonderful where you want to add extra information. What's also nice mentioning is with Granite, you can also use the InstructLab technique and do fine tuning and actually tune the model as well. So a lot of good options there. So let me go back to the presentation. You can do the fancy stuff too, right? So with Granite, and we've got examples of this here. So we have recipes for doing low rank or lower adaptation, which basically allows you to add behavior to your model. And the example we provide allows you to generate citations and scores on the likelihood of hallucinations. So if you look at the bottom, there is a Granite community cookbook recipe that you can look at. We've also got a nice recipe for how to do RAG with Granite. So yes, I did it the easy way and did everything through anything LLM. But folks who want to have more hands-on experience and understand how you put all these pieces together, we've got a recipe that's going to show you how to do that. And it leverages Dockling. Dockling allows you to process different document types, whether it's PDF, HTML, what have you. Very popular tool that we've got working with Granite. So definitely check out the fancy recipes there. And just a little bit of inspiration on other things that we've built. We've got a local code assistant where we've got Granite with a llama and continue. And, go check this out. There's a nice link here. And you can see how we put all this together to give you that end-to-end application. We've also built a little personal knowledge agent. And again, with Granite, AG2, Open Web UI. So you can see what we did there, and you can have your own little personal knowledge agent working for you. So hopefully all of this gives you a good feel for how you can leverage the family of Granite models. Again, you can trust them. They're all different sizes, and you can run them in constrained environments. You can run them laptops. You can run them in bigger environments. And you have great RAG examples. You have great ways to fine tune it with things like InstructLab. So definitely check out, and then of course we have the Guardian stuff as well. So, you can feel comfortable using it. So we think we've got a lot to offer here. So at this point, I'd like to say thank you. And I think we're ready to take some questions. And let's see if we have any questions in... are there any questions? So I don't know if there's a way to find out if there are any questions for the moderator. Lucas, is there a way to know if there's any questions?
I'll post them in the private chat for you guys. Let's just give it like 30 seconds to a minute while people type some questions up.
Okay. It's always good when live demos work just fine.
Congrats.
Yes,
Yeah, you're brave for doing a live demo.
Live demo with a, that was a pretty big one, right, Abraham? I mean, did you see? That's a pretty big model I was using there. So you go, oh, I'm running the model, I'm running the live stream stuff. Is the machine, the lights in the house going to start dimming? But it ran pretty fast, and then even the RAG technique ran pretty fast too, I think. So, go ahead.
So I see a question, can this model be used for face scanning technology? So right now, the capabilities of our Granite language, the models that I demonstrated, the Granite language embedding, as well as Granite Guardian, does not support face detection. We are working on a Granite Vision model that will specifically focus on document understanding. It does have the ability to ingest images, but given the scope of our kind of client base, we're really focusing on supporting document ingestion, so UIs, charts, tables, things of that nature. So that'll be image and text out. So just in short, no, not at the moment.
I'll take the question on installing anything on. No, it's you got to have a llama, because a llama is where you're gonna run the Granite model. It's gonna, and the anything LLM is more just sort of that nice web interface that also gives it a nice GUI interface that also allows you to do the RAG pretty easily. So yeah, you're gonna want to have a llama and anything LLM. So I took that one, and then Abraham, I don't know if you want to take the last question there, because it's more in the guarding.
Yeah, so the question is, what's the best way for guarding against queries from end users? Is there any specific Hugging Face LLM model that prevents this? So for the first question, what's the best way of guarding against so that would be a guardrail. So kind of like I explained, as part of the Granite Guardian model. So that sits on the front end of the model, and you can outline a specific risk detector that you want to be able to target. So that's your best way of actually enabling or managing user queries on the front end. There's a number of models. There's our guardrail, there's our HAT model, there's, as well as, like I mentioned, Llama Guard, as well as other ones. In terms of, is there any specific Hugging Face LLM model that prevents this? Yeah, the ones I just outlined. So again, being a Granite advocate here, I would say experiment with our Granite Guardian at 8B and 2B, given your environment. And then on Hugging Face, we also have our, I believe it's 125 parameter Model 2 for HAP detection. That is a little bit more efficient and less costly.
And did you see the question? They want to know if they can access the model on GitHub. You want to, Abraham, call all the places they can access the model?
Yeah, so right now the models are available on our IBM Git repo. I don't know if you saw the link, but our IBM Git repo on Hugging Face. There's a number of partners that we work with if you need an endpoint, access to an endpoint. So Olama, LM Studio, as Eli mentioned, partners are with Docker, with AWS, NVIDIA. So there's a number of places in the ecosystem that our models can be accessed from. Please visit ibm.com/granite if you want any further kind of information or outline on where to find them.
And then Eli, I think there's a good question for you. Are Docker containers a viable solution for deploying and running these types of models? If so, what are the potential challenges or limitations we might encounter when containerizing such workloads?
So as I've demoed and talked a little bit in my presentation today, of course, containers are a viable solution. And we're seeing lots of developers using containerization for deploying such models, interacting with those models, and using it as a language. Limitations are typical limitations one would have with models, right? The hardware limitations of the underlying machine you're running it on. But anything you can run on a local machine, you can run with containers. Anywhere you can use containers, you can run them with models. Any other questions?
It looks like that's the end of the questions. Thank you, Lucas.
Yeah, thanks, Lucas.
Thanks, everyone.
Yeah, go ahead. Yeah, thank you, everyone, for attending. We do appreciate it. Enjoy the rest of the conference.
Yeah, and I kind of got ahead of myself. Abraham Daniels, Senior Technical Product Manager over at IBM Research, focus on Granite. So if you have any other questions, feel free to reach out in any other avenue.
Fantastic.